You can do this through the Optimize tab and comparing the files. The file on the left is the original NC program. The file on the right, the output optimized NC program, as evidenced by this banner at the top of the file. So what I want to point out for you is, here is the original NC program feed rate for the very first operation of the very first tool, 29 inches a minute. In the optimized side of things, we see that as well, but then the tool was in error, so it was increased automatically by force optimization to 750 inches a minute while the tool's moving in air and not removing any material, and then slows down prior to engaging material. But after that, look what happens with all of the feed rate scheduling that goes on and block breakup. This is the amount of subdivision that causes very precise, constant chip thickness at the ideal thickness you want for machining this material. Nothing like the program that came out of the CAM system. So that's what's causing all of the savings. Some people think that by having all of this feed rate activity, that causes some erratic machine behavior. But in fact, what's going on is it's causing the machine spindle and the spindle load to run much more evenly than the original NC program. So the benefit to the machine is significant, as well as the benefit to the tool life, keeping that constant chip thickness right where it needs to be for machining. We have our force users reporting from 2 to 3 times tool life what they get with force optimized programs. Now VERICUT's reports are customizable, and this is just one of the templates that comes with the software, so I'll put my name in here and go ahead and save a report. What the report in this case will tell me is what material I was machining. Did I have any errors or warnings in my program? Earlier you heard me say it had already been verified to not have any, so I expected nothing there. A summary of your savings, the files you used, and then here's a summary of the tools that ran and were optimized. Each one's listed by the description in VERICUT's tool library with a picture and where it was loaded on the machine or how it was called at the machine. I've documented what the optimization settings were for each tool, and then it gives me the original runtime, optimized time, and the difference. So 45% savings, 22% savings, 43, 50% savings. You can see that the savings are dramatic in this case. Now here's a tool which actually has a negative number reported, which you might think is odd. Well, what happened in that case is the tool was originally programmed too aggressively for the finishing operation it was scheduled to do. So what force optimization did was notice that the chip thickness was too high, and it adjusted the tool feed rates downward to make it run properly and give the best finish that it could. And that's all of the green area that we see here. That's where that happened. So even though it's reported as a negative savings, it's significant for having the best part finish that's needed. And as a programmer, what's nice for me is I didn't need to keep track of that. Force just took care of that for me and took my roughing feed rate I had in there and fixed it. So that's a great savings for me as a programmer. And down here we have the tool use bar, so you can get that same visual look that we saw here in VERICUT as a reference of how much savings there were. So a nice example of VERICUT reports.